All right, we're in section 12.2 where we are going to look at surface area of prisms and cylinders. So when we're looking at surface area of these three-dimensional objects, we have to take into account essentially um, three main components. So when you look at a three-dimensional object, it has these three components. It has a base, which means it probably has two of them, one on the top, one on the bottom. It's got lateral edges that are connecting those two bases, and it has lateral faces. And the number of lateral faces is basically dependent on how many sides each base has in a particular example. So first things first, what they want us to do initially is to create what is called a net. So a net is a two-dimensional representation of the faces of a polyhedron or 3D object. So in this one here we have a rectangular prism, and what I notice is I'm going to call these pieces here the bases. Okay, so like looking at it this way and looking at it from like behind the object. So those two pieces are going to be my bases. All right, that means that this piece here, this piece here, this piece underneath, this piece to the left. Those are all going to be my lateral faces. So to draw this, I'm going to start with one of the bases. So I'm going to go and say this is my base. And then from each side, I'm going to like, okay, here's one lateral face, the second lateral face, the third lateral face, and then finally the fourth lateral face. And then finally to draw in that second base, you can choose any one of the four lateral faces to try to draw it off of. So I'm just going to draw it off of this one here. I'll call this one the base. So if you were to kind of like fold it in like a box, this would be your two-dimensional representation. If you look at this cylinder here, one of the main things that you have to do is, all right, what is this shape going to look like, you know, these lateral, off of these lateral edges. So almost if you were to take it in an example, kind of make it like almost like sheet metal and roll it out. When you roll it out flat, the 2D representation of this is going to be a rectangle. So, really very similar when you have like a uh, roll of wrapping paper for gifts, whether it be birthday or Christmas or something like that, and then you roll it out and get ready to wrap it, it shows up as like a rectangle. Now, so this is like essentially our lateral face. Now what we got to do is on each side is to create this base. All right, the base is the circle. So I'm going to have a circle here, and I'm going to put a circle here. All right, this is a crummy circle. I'm going to redo it. That's better. So here's our 2D representation. The only thing that we have to keep in mind is the distance from here to here is going to be the circumference of this circle. So essentially it's going to be 2 pi r, and whatever the radius is, or pi times d, whatever formula you like to choose from. Okay. So essentially here are the two formulas that we're going to kind of look at when it comes to surface area if we're looking at a right prism or if we're looking at a right cylinder. So For this one, it's going to be 2b, which is the area of the base, plus area of the lateral faces times by the number of lateral faces. If we look at the cylinder, it's going to be 2 times the area of a circle, which are the two bases, essentially is b like we have here. And this right here is 2 pi r, which in this case is the circumference of a circle multiplied by its height. So, first things first, they want us to sketch a net of the figure, then they want us to find its surface area. So in this one here, I have a 1, 2, 3, 4, 5. That's a 5-side figure, so it's like a pentagonal prism. So I'm going to draw my pentagon, and then go here, and then my lateral faces are gonna come from there, here, 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 and here. And then finally, you're just going to draw another pentagon. So 1, 2, 3, 4, 5. So I'll say this is my base and this is my base. Next, they want us to find the surface area. So the surface area is going to be equal to 2 times it by, in this case, we got to find the area. Now, if you remember back from chapter 11, we have a regular polygon, which is 1/2 times by the apothem times by the perimeter, and then it's going to be plus uh, the area of the lateral faces. So there's going to be what, 5 of those times by the area of those. In this case, where it's going to be what, 14 times 20. So we got to find the area of our bases. So essentially, we got 1/2 times it by the apothem, which is 11.6, times it by the perimeter, which is 14 times 5, which is 70. And then I got this 5 times 14 times 20 over here. So solving all this out, if I were to take 2 times 1/2, that essentially cancels each other out to make 1. And I got 11.6 times by 70, I get 812 right here. Plus 5 times 14 times 20, I get 1400. Add those together, I get 2212, and I have it as square units. Okay, so essentially with this one here, it's just like what we did at the previous example. Make your rectangle and then put your circles in there. So that would be the net for this one. For the surface area, the surface area is going to be 2 times the area of a circle, which is pi r, which is 3.8 squared, plus we got 2 times pi times 3.8 times the height, which is 7.2. Okay, so for all of this, well, I'll use approximation, so I'll create pi as 3.14. So 3.8 squared is 14.44. Times that by 3.14, and then multiply that by 2. So now I get a value of 90. We'll say 68 for the first part, plus I got 2 times pi, which is 3.14, times it by 3.8, times it by 7.2. I get 171.82, so 171.82 plus 90.68 gets us what, 262.5 square units. Okay, so with this particular example, it's a little bit um, trickier because, uh, for one, it's hard to determine which one's your base, so and which ones are going to be your lateral faces. So first, I'm gonna start with the net. I'm gonna start off at the bottom. The bottom piece is 36 by 12, and then off of that we got, this is 20 and this is 20. But from the other side, this is going to be 20. This is going to be 20. And then finally, I will make the other base, which I'll put right here. And then this will be 12, and this is 36. So this is my base, this is my base. So if you look at the net itself, I have two different sizes for lateral faces. I have one that's 12 by 20, and I have another one that's 36 by 20. So when it comes to finding the surface area for this particular example, what we're going to do is we're going to take the surface area equals, and if you notice, each dimension has two rectangles. So I have two of them at 36 by 12. Those are the bases. And then I'm going to add it by two of them that are 12 by 20. So this one and this one, plus two of them that are 36 by 20, which is here and here. So go about solving this one. I got 36 times 12 times that by 2. I get 864 plus 12 times it by 20 times it by 2 gives me 480 plus 36 times 20 times it by 2 gives me 1440. Let's add those together. So 1440 plus 480 plus 864 gives me a surface area of 2,784 square units. Okay. All right, and then in these situations, they give us the surface area. They want us to find the value for x, and in this case, uh, the value for x in this case is the height of one of the lateral edges. So very similar to the problem that we just looked at. This is where we have two different sizes for lateral faces. So we can look at the two bases. We're going to have two bases that are dimensions of 30 by 8. We're going to have two of them with dimensions of 8 by x. And we're going to have two dimensions that are going to be 30 by x. So when we go about solving this one, again, we're going to have three separate addition problems. We're going to have the surface area, which in this case is 1848. It's going to be equal to 2 times the area of this one, so 30 times 8, which is 240, plus 2 times the area of this one, which is 8x, plus 2 times the area of this one, and that is 30x. So when you go about multiplying each of those individual problems with the separation of addition, we get 1848 is equal to 480 plus 16x plus 60x. I get to combine these two for like terms. So now I have 1848 is equal to 480 plus 76x. I subtract the 480 to both sides, so that gets me 1368 is equal to 76x. Divide everything by 76. 18 is going to equal, or x is going to equal 18 feet. Sorry. If we look at this value here, we have a surface area of 5,505 square inches. So now, actually, let's do this. Surface area is 5,505. It's going to be equal to 2 times the area, which is pi, in this case 10 squared, plus so we got 2 pi r, which is 2 pi 10, and then it's going to be times it by h, which is x. So going about solving this, I'll look at this one first. 10 squared is 100. Times that by 3.14, I get 314. Times it by 2, so I got 5,505 is equal to 628 over here, plus, now if I go 10 times by 3.14 times it by 2, I get 62.8x over here. Subtract 628 to both sides, so 5,505 minus 628 is equal to 4877 is equal to 62.8x. Divide that by 62.8. X is going to be roughly 77 point, we'll say 66, and it was inches. And that is being able to use surface area of prisms and cylinders. Hope this helps. Until next time.